Hello, good morning. Yes.
Good morning. Okay, you can start if you want, if you are ready.
Thank you very much. One moment, we'll share the screen.
Please, you have 10 minutes
Okay.
for presentation.
Okay, I will stop the camera and I will share the PowerPoint.
Okay.
Okay, thank you. Can you see the presentation?
Yes.
Okay. So, good morning, ladies and gentlemen. My name is Andrei Alexandru from Polytechnica University of Bucharest, and today I will present you the paper Gaussian mixture model application in deforestation monitoring. I am also working in the Romanian Ministry of Defense on a daily basis, which has some implication on my presented work. A quick review of the table of contents. We will start with the status of deforestation and we'll continue with the aim of research and describe the database used and different scenarios of the GMM algorithm. In the end, we will show which one performed best and how the evaluation was made. Historically speaking, deforestation started a long time ago, but the process was slow and the forest had enough time to recover. Along the way, with the demographic explosion and industrialization, things have changed for the worse. It is estimated that half of the total forest is lost since the beginning of time. Only in the last century, 10% of the world's forest has been cut down to make space for crops or grazing land, with a peak in the 80s. In that decade, the area that was deforested was the size of today's Mongolia. International associations such as the European Union or non-governmental organizations regulated this activity to get an optimal balance between cutting down trees and forest regeneration. But there is no real hands-on method of enforcing the law. The aim of this research is to lend a helping hand to environmental activists by finding a global, easy-to-run method of deforestation detection using an unsupervised machine learning algorithm applied on its own set of digital frames. Also, until now, two previous works have been made. The k-means and agglomerative nesting algorithms have been implemented, so the accuracy obtained was desired to be enhanced. The raw database is composed of aerial images collected using a push broom airborne digital sensor and are the property of the Geospatial Defense Intelligence Agency. The sensor can record RGB or infrared with an 8-bit radiometric resolution and a 50 centimeter spatial resolution. The area studied is from Roșia Montană and Târgu Mureș, two counties from Romania with a rich cover of forests. One important advantage of the data is that the flights are always made when the weather allows it. So they are very clear, meaning no clouds or noises are present. And here you can see the two types of products. After the processing are obtained the RGB images and color infrared. RGB images, of course, represent the natural image as perceived by the human eye, and the color infrared images represent the overlapping of the red, green, and near-infrared bands. The latter is very useful because they provide accurate information about nature. The brighter the infrared band is, the denser and healthier the vegetation is. Because the two bands of red and green are found in both RGB and color infrared images, but in different order, we had to solve this problem by extracting each band from the RGB images and the first band from the color infrared images, concatenating them and save the new formed image. The initial dataset as produced by the institution is organized in tiles of 100 square kilometers, meaning that every image has a dimension of 20,000 times 20,000 or times 3 pixels, which is big, to say the least. For computational and testing reasons, up to 100 times smaller datasets have been made by splitting the initial images on length and width. On the right, you can see a 4-band image as a default representation of a computer software. The method presented in this paper is the Gaussian mixture model. This falls into the unsupervised machine learning techniques which more precisely into the clustering category. Unfortunately, one Gaussian distribution does not generalize enough in order to explain the complexity of a multi-band image. For this, a Gaussian mixture can be assembled using K distribution. In this case, our K is also the number of clusters of the dataset, and each Gaussian describes one cluster. The linkage between the Gaussians is done using weights that must sum up to 1. To find them, expectation maximization techniques has been implemented, which is an iterative one, based on the calculus of the maximum likelihood of the previous step. Having to deal with 4 bands and such big data, we had to experiment with more than one scenario. Besides the obvious parameter k equals 2, the rest of the GMM parameters had to be tuned. We had seen in the previous work on the K-means and Agnes algorithm implementation that more data is not necessarily more useful, and the 3-band dataset outperformed the 4-band. The near-infrared output, as you see on the right, was expected. The GMM algorithm could not find any pattern with solitary information. The other 2 outputs at first glance look similar, but the 4-band image performed slightly better. The RGB output was overall noisier and had missed cluster regions like the ones marked, so the decision was taken to continue testing on the 4-band dataset. The next parameter to test was the analysis window, which is the input dimension of which the calculations are made. This way, the algorithm sees closer or farther the ground truth that you want to show you. To experiment with this, we started with an initial 20,000 4-band image, which was fed to the GMM algorithm, and subsequently reduced the input to smaller areas such as 4,000, 1,000, and 200. The evaluation has been made from 2 points of view: the classification quality, of course, and the time to compute each input. And this is presented in the below table using seconds as the measurement unit. Total time represents the average time to compute all the inputs that computes the upper level analysis window and is calculated by multiplying the number of inputs and the average time rows. The best results have been achieved for the 4,000 and 1,000 input dimensions. Being an iterative algorithm, the expectation maximization has 2 specific parameters: the convergence threshold and the initialization method. For the convergence threshold, negative powers of 10 have been tested, the best one being 10 to the power of -3. Also, 3 initialization methods have been implemented: the K-means algorithm, the mean of all points, and the random initializations from data points. The worst results were achieved by the second one, the mean of all points, so it was discarded in the process of final evaluation. The main difference between the random points and the K-means initialization is the classification of 3 shadows. Random points classify shadows as low forest most of the time. Depending on the location, this can be desired or not. For example, in 1 and 2, correct classification occurred, but in 3 and 4, on the contrary. On the other hand, K-means initialization classifies the shadows as forest most of the time. You can see in the image that the trees are stretched and are represented a little bigger than their actual shape. Having to calculate accuracy for so many outputs and taking into consideration that the images are unlabeled, a team of geospatial information system experts was utilized. Every ground truth sample has been labeled in 5 classes concerning the size of the forest area, each corresponding to a percentage. Next, for every output, we calculated the amount of forest clustered and rounded to the nearest label class. In the end, the accuracy was computed by comparing the 2 values. Previous work on deforestation monitoring using the same dataset has been done, and the accuracies are as follows: 85.56 and 87.78%. The final accuracies of the GMM for different scenarios are shown in the table. The best results have been achieved using the 4000 input. In this case, both of the initialization methods performed very well, and the difference between their outputs consisted of a small number of pixels being classified differently, which had no real impact on the final accuracies. Using the random points initialization for the 1000 input performed similarly to the previous work, in opposition to the k-means initialization which had better accuracy. Here you can see a final classification output of a 4000 image. On the left you have the ground truth, and on the right the segmented image in the two classes of forest and no forest areas. In conclusion, in order to monitor deforestation, three conditions must be met: to occur digital frames at different times in the same coordinate system and using the same bounding box on the ground truth. We can safely assume that this algorithm has a good accuracy for an unsupervised machine learning technique, but is more complex to implement than the previous one, like the traditional k-means. As for further work, it can be tried to classify image in more than two classes in order to extract the three shadows, to pre-process the pixel values before feeding them to the GMM algorithm, or to use NDVI index as a better evaluation tool. NDVI stands for Normalized Difference Vegetation Index, which is an index that is calculated using the near-infrared band and the red band. Thank you for your audience, and if you have any questions, I will gladly respond to them.
Thank you for your presentation. Dear participant, do you have any question about the paper? Okay, no questions. Thank you again.
Thank you very much.
I wish you success in your career.
You too. Thank
you. Next paper belong to dear Camilla Wells. Are you ready to present?
Yes.
Okay, you can start your presentation. You have, yes, you have 10 minutes, please.
Excellent. Good evening from Australia. My paper is going to be quite different from the previous, and we'll soon see. First, from Australia, we always begin by acknowledging that the sovereignty of the land from which I present has not been ever ceded, and so we acknowledge the traditional owners of the land before we begin our presentation. Thank you. Today, the paper I'm talking about is not very technical. It's much more on the social sciences side of things. So it may seem a little out of place in the conference today. But what I wanted to talk with you about is closing that quality assurance feedback loop on recommender systems that tend to be AI or ML based. Before I go into any more detail about closing the feedback loop, I firstly wanted to establish the definitions or the context from which we're talking about in order to really get an understanding of what we're talking about. And also because of the increasing range of recommender systems, I wanted to broaden the definition from the pure technical ML or AI. And it's more than just Netflix these days. So we need to broaden this definition to be technologically agnostic and to consider more higher impact decision making. So I wanted to talk about models that are being used when we have that outputs a recommendation for a decision at hand. And for this particular scenario, I chose to look towards the criminal justice context, because we have a number of different models, tools, all sorts of recommendation systems that are being implemented. And as we, for those of us who work amongst, say, government administration or just general administration, we know that we have to do more with less. So there are more and more of these recommendation tools being implemented across the place. Earlier this year, I was listening to a conference where a colleague of ours, Sarah Chen, discussed the idea of being an exception to these systems. And that really hit home to me, where I thought, hang on, we can actually build that and we can automate it. We need to think a little bit more carefully about the harm that some of these systems are potentially impacting on those who are the subject of those decisions. So while often we can look to the amazing example before of looking at deforestation, we also need to have a look at how we are implementing these systems in that social decision-making context. For example, if we're looking at a pre-trial risk assessment, do we send someone to jail or not based on the recommendation of a system? If we focus on the right to be an exception, then that shifts our priority away from finding the perfect model. And that gives us the opportunity to look to our quality assurance and actually figure out how we can close that feedback loop. I noticed when I was looking around that the US FDA already has outlined that there is a closure to the feedback loop as a part of their software as medical device. And so when you're doing QA for software as medical device, there is the anticipation that there is the model monitoring and tracking over time, and that it actually provides feedback. How often is this done then in the social decision-making context? If we have all of those different recommender systems in place in our judiciary systems, is that feedback loop actually being closed? Are we actually getting that data back in for retraining? When I looked around, I could not find any social decision-making contexts that have recommender systems where the feedback loop is closed. If anyone on the call actually knows of any particular examples, I would love to hear about them. So in finding that there was this gap, that we haven't necessarily closed that feedback loop, I looked to build a solution for that. But if I was going to do some kind of a closure of the feedback loop, I couldn't do it on my own. It is silly for me as a software developer to do that kind of project. What I must do is I must collaborate with colleagues who know the area. And so I got in contact with a colleague who is a legal advisor, a lawyer, and together we were able to actually work through a co-design to actually figure out what can we do with this validator. We built up a proof of concept based on a theoretical scenario. In order to be able to actually do this kind of software development thoroughly, we actually started at ground principles and began with that process design document, the requirements document. You know, the thing that really grinds our gears when we have to actually do this stuff as software developers, we don't really interested in documenting necessarily all the time, although that's probably quite harsh on our area. But that's where we began. And by doing that, we were able to actually lock down what those relevant policies, procedures, legislation, what are those laws that are actually applicable to the systems that are in place in this particular context. So if we're talking about the remand or bail context, is there a law that actually outlines particular thresholds that we need to abide by? So through this co-design, we were able to actually flesh out all of those fundamental thresholds that are actually based on legal precedents. That then gets translated into deterministic logical expression and is then translated into the code. So we've gone from that social context through this type of documentation to be able to translate it into actual code, to be able to, for myself as a software developer, to be able to code it up. So for instance, for this particular scenario, what we decided to do was think, okay, supposing that there was an existing criminal proceeding system and supposing that they already had some kind of a recommender system that provided a recommendation on whether or not the person would actually re-attend the trial or go into, were presenting as a high risk for failing to attend or for for committing more further crimes. So supposing that that was the scenario, supposing that we had all of these things lined up. So again, unfortunately, this has to be theoretical in place at the moment. for the proof of concept. So supposing we had all of those things, the system that we built, VAL, was able to provide those calculations based on thresholds, those deterministic logical expressions are able to go, hang on, this person in this scenario is an exception to the recommendation that this system has provided. This person does not match those key criteria. This person is outside of that threshold. So when the recommender system has provided a high risk rating or some such, which can have a huge detrimental impact on that person's life, the system, the validator that we have built, highlights the fact that this is actually an exception. If you think of the load of the development of this kind of system, you would have a core amount of work that would have already been completed on the actual recommender system. This is just the final icing on the cake that actually just rounds out, but also is an external validator of the system. In order to make sure that this proof of concept was actually relevant, useful, worthwhile, I did functional testing and again went back to my colleague to make sure that it actually made sense, that it's user-friendly, those sorts of things. I also made sure that I pulled out recent examples from our own news where we've had very unfortunate cases of people being released from on bail or not being released on bail and have had huge negative impacts on their lives, and using those case studies to validate that this process actually works. A further benefit that I didn't even realize at the time, but now has become apparent, is the idea that you can actually cumulatively look at the performance of the recommender system over time. If there is noticing that certain components are starting to fail, or that there is an increased amount of exceptions to the rule of the recommender system, then the feedback is able to get to the team who are working on the recommender system to actually pull those levers and make sure that the model is functioning appropriately. From here, I know that there is a lot of scope to improve. There's definitely a lot of areas that were cut out just to make sure that that small proof of concept could actually work. And so I know that there's much more to be done with that. I definitely want to build this on a more easier to share platform as well. And I also am looking to do a live implementation. I'm also very welcome any feedback and any comments from anyone here and otherwise. If you have any questions, please don't be afraid to reach out. Thank you so much for the opportunity to share.
Thank you for your presentation. Dear participant, do you have any question about the paper? Okay, no question. Thank you again. I wish you success in your career, dear Camilla Wells. Okay, next paper belongs to dear Veska Ganjeva. Are you present? Dear Veska Ganjeva. Okay. Next paper belongs to dear Kostas Peppas. Are you ready to present?
Hello, everybody. Good morning, everybody from Greece. Can you hear me?
Yes.
Thank you. Just
if you are ready, please. You can present your study.
Can you see my presentation?
Yes. Yes.
Okay, thank you very much. Let's see.
You have 10 minutes, please.
Okay, I'll try to be as soon as possible. Ladies and gentlemen, I'm Kostas Peppas from the University of Peloponnese, Greece, and this presentation will be about a preliminary auditory perceptual evaluation of resonance for the implementation in an AI and artificial intelligence system. In brief, AI and machine learning can be part of projects such as resonance disorders and nasality problems, referring to a problem that can be recognized during speech population in both children and adults. The purpose of this study was to explore the dynamics of implementing an auditory perceptual evaluation protocol based on an AI scheme in a monolingual Greek-speaking preschool children. Our results have shown that the proposed AI scheme can be efficiently used to improve assessment outcomes of reasonableness problems in preschool children. And our findings, we believe that they can lead to better, more accurate clinical decision-making and diagnostic accuracy of nasality. Well, typical work-speech resonance is the result of proper and balanced sound energy from the laying throughput, the oral and nasal cavities. That normally not typical resonance productions can result from structural and functional etiologies. Back to 1914, Fletcher and others have introduced in the literature the so-called nasalance term in order to describe the measurement of the velopharyngeal mechanism during speech production. Several works have revealed the problem. Just try to become as soon as possible. Motivated by the above facts, we have implemented an iterative speech logic, whereas the results are estimated as being a part of a machine learning procedure. Our goal was to show that each estimation acted as a different entity, ensuring the best possible objective results in this preliminary implementation study. This AI system we have implemented will be imminent because the prototype version will follow 3 experts' opinions as being the 3 entities of the AI. Ideally, we need some more entities in order to properly predict options, a plethora of options, take into consideration the best possible overall multiplexing. Let us discuss some things about the architecture of the proposed AI system. This system consists of 3 standard levels of awareness. The first levels it includes 5 sectors and the suitability, e.g. the suitability estimation of the administered test, the detection prognosis by the entity, the development and self-calibration of the overall procedure for better evaluation, the continuous monitoring of the AI system, and finally, the application of the neural networks for enhancing the accuracy of the computations. Next, we present some more details on the architecture of the proposed system. Its sectors includes a machine learning pipeline consisting of 22 stages, which are further grouped into 5 major categories, namely defining the goal, data acquisition, data preparing, training processes, and finally, the running model. In the third category, namely the data preparing, an empathetic essence is providing for mixing the mathematical genius of the artificial intelligence with the human perception and the ability of understanding. And this essence is named the 12th stage of the overall 21 stages available. Some further details on the implementation mechanism. Inside the mechanism, there is a redesigned 7-stage logic that includes a new stage called hereafter as primary case sensitive details. The last stage is needed for the CLT for comparing the final stage past data of human experimentation with those of the machine. In turn, if large deviations would be expected compared to the same conditions and cases, then the AI system runs the whole process, but by excluding extreme cases until it reaches a result which is acceptable. And this result will further be the limit between the first result and the expected ones with low variance due to data exclusion. Also, the procedure is finally staged as an additional procedure of quality control and for future predictions that can have the lack of human experimentation data. Now, excuse me, how to match the utilized methods with the AI scheme. First, data insertions should be conducted during the first stage of the machine learning algorithm we have already described. After the evaluation of the data, these are driven for evaluation and processing through the 4th and the 3rd categories of the algorithm, which are hereafter called data preparing and training procedures, respectively. In the 12th stage, the data are re-evaluated using analytical techniques, whereas in the 3rd level of awareness is applied. The selection of methods, mathematics, regression methods, statistical methods are further implemented during the 4th and the 5th categories of the algorithm. And then the results are acquired for further processing for the output of the system. Okay, some details of the evaluation and emulation of the proposed AI scheme. First, we have gathered 100 monolingual Greek-speaking children, namely 52 boys and 48 girls, with ages ranging from 3.6 to 5.9 years old, that is a mean of 5.01 and a standard deviation of 0.0 1984. All these children have participated in the study under consideration and have been recruited from nurseries and kindergartens in Greece. The participating children have a typical development, and the children who participated before enrollment have undergone a speech and language screening assessment. All the informal parents have received complete information for this study with a consensus letter and have signed a form, a corresponding consensus form. The protocol for the evaluation of the study has been developed based on using the existing literature for assessing an assessment base on the word stimuli. The Mason and Grandstaff method has been developed for evaluating this mechanism, and this subject in this method has been recorded and asked to count from 60 to 100. Then the evaluator in every production have taken into account specific sound changes during the evaluation, and finally, according to this protocol, the so-called mother tongue anchor technique has been employed for predicting biopharyngeal closure. All the above has been translated and adapted to the Greek language using a minimum translation criteria. This auditory perceptual evaluation protocol has further undergo a pilot validation before using in the proposed project. In order to further evaluate the proposed scheme, we have employed the so-called SAPIEN protocol, and the recording of the samples has been performed using a digital recording system. Then the 3 samples, recorded samples from each child, has been given for further evaluation by 3 different SLPs, namely 3 raters, using the AI scheme proposal. The evaluation of the samples has done independently for each evaluator, and the evaluators have been asked to rate with 0 non-nasal, 1 slight, 2 moderate, and 3 severe. And these scores can be attributed to a total grade for the existence of assailants. Consequently, the 3 raters have corresponded in this case to 3 different mechanical entities of the AI system for accomplish pluralism in their prediction. And in this way, the total results can be a combination of just a mean value for every measurement in a fully functional AI machine learning system. Now, we have further analyzed the results using the so-called Kolmogorov-Smirnov and Sapir-Whorf test for normality assumptions. We have conducted t-tests in order to compare the means between the initial and the final scoring of the SAPIEN total score. If the evaluation, in the evaluation of the agreements between the raters, the kappa coefficient has been calculated and the statistical significance has been set at less than 0.05. The t-test which have been conducted was used for discovering any statistically significant mean difference between each sample and between raters. And finally, the kappa coefficients have been used for the level of agreement between the 3 raters for the 3 speech samples, as well as for each raters within the 3 samples. The per sample test has been further used for finding significant mean difference between samples and between raters, and the kappa coefficients has been used for level of agreement between 3 raters and the 3 speech samples, as well as for each rater within the samples. The first recorded sample, the results have shown no significant difference between any combination of the 2 raters. The evaluation of the second sample has shown that the results return no significant difference between any combination, and the evaluation of the third samples have shown that the results return no significant difference or no analysis in case of equal scores from the raters. The evaluation of the 3 coordinate samples for rater N have shown no statistical difference. The evaluation of the 3 samples for rater V2 t-test no analysis, since the rater attributed equal scores to all 3 samples. And as far as the third rater is concerned, we have observed statistically significant difference only between the second and the third samples. In order to determine the level of agreement, we have evaluated the kappa coefficient, which so that our findings have shown that the results have returned a significant difference, significant correlation between every combination of 2 raters for the third sample, statistically significant correlation between every combination for the second sample, and a statistically significant correlation between every combination of 2 raters for the third sample. Some discussion. This study is a first attempt, to the best of our knowledge, to present a short auditory perceptual evaluation of assailants that could be a part of a further, more complicated AI system for better diagnostic outcomes. They use the so-called SAPIEN system comes in agreement with results that have already been reported in the open technical literature. The Likert scale can be easily implemented in a machine learning system in order to quantify various levels of decision making. An ideal solution would be an analog visual scale that could be emulated to a plethora of discrete scores. An AI system having matching parameters to the study may outperform because every aspect of measurements, including the three ratings, would be waiting for the final scores to be more accurate and reflect as much as possible the results for a vast study. So in this study, apart from the AI design proposal and data analysis on the selected clinical case, 3 liters have been used to emulate the AI working conditions in this way to understand potential medicine problem. Soon, we are going to implement a more customizable and fully automated system in order to test our experiments and our theory under hospital conditions. So, thank you very much for your attention. If you have any questions.
Thanks for your presentation. Dear participants, do you have any question about this article? Okay, no question. Thank you
Thank you
again.
very
I
much.
wish you success in your career. Next paper belongs to dear Ruhi Sille. Are you ready to present?
Yeah, Ruhi is there. Ruhi, yeah, fine. Thank you.
Okay. If you are ready, you can.
Ruhi, you are not audible. Your mic is not, I think, muted. You are not audible.
Dear Ruhi Sille, we can't hear you.
I
Good
think,
afternoon, sir. Am I
sorry?
audible?
Yeah, Akshita, you are audible. You may present.
Yes, sir. Yes,
Yeah,
sir.
thank you. Thank you. Please go ahead.
Yeah. Good afternoon. Today I will be presenting our topic on review study on blockchain, frameworks for security issues and IoT devices. Below mentioned are the
Okay.
authors that have contributed. in
Sorry,
the
you
research
have
paper.
10 minutes, please.
Yeah, thank you. So with the advancement of technology, we can see that one of the trendiest technology is the blockchain. Here in the paper, we present some of the key findings related to how the authentication, authorization, and access control in the IoT environments can be dealt with the involvement of blockchain concepts. As we move to the introduction, people, places, and products are connected through the Internet of Things, which has immensely impacted the businesses and has enabled more efficient ways of working. And with this advanced uses of IoT, preventing unauthorized access to valuable resources is a top priority when it comes to computer security, also called as access control or authorization. Mentioning these several challenges that devices may face, including like difficulty in implementing, monitoring, and maintaining. Also, when we talk about centralized security infrastructure in any company where IoT devices are used, attacks like DDoS are also possible. With this, as blockchain technology moved towards decentralized architecture, and it has gained a lot of attention when it comes to addressing security, anonymity, traceability, and centralization concerns. As a result of this distributed nature, blockchains are always available. And when these blockchain technology help IoT systems, it can basically enhance with the technology to achieve a distributed consensus-based IoT system that addresses security concerns. This is what we have included in our paper. Now, as we can see in the next page in the diagram, that how blockchain can be integrated with the IoT, we can basically resolve issues of access control, authentication, and authorization, which will resolve the security challenges like unauthorized users using those devices, lack of access control, or untrustworthy actions in the environment. So around our research and finding, we first move to authorization. Authorization basically means that whenever any device is being used, it gives the permission of who the person will be using that device. So when we see for authorization, as you can see in the table on the slide, there are many key concepts of blockchain that can be used for authorizing the IoT devices. For example, the chain anchor architecture. This anchor architecture was developed by T. Hardjono author in the year 2016. Such like that, for example, Fair Access, which is a platform which can be used for authorization management. And a Genesis network is used for facilitating peer-to-peer identification of how IoT devices are being used, etc. like two-factor authentication protocol, use cryptographic delegation. Moving ahead with authentication. Authentication means that whenever you are authorizing somebody of using any device, but before that, to identify the person and verifying that person is also necessary. Based on that, some key research around how authentication of IoT devices can be done using blockchain are based on Ethereum and smart contracts, DSEIN, which is a blockchain-based secure mutual authentication, which uses fine-grained access control system. These researches were done in the year 2017 and 18. Next and lastly, access control. Access control defines what resources can be accessed and used and in what way it can minimize the risk of unauthorized actions based on the accesses we are giving to the user. The basic models which are defined through blockchain for the access control are an organization-based access control model, role-based access control model, ciphertext policy attribute-based encryption is also available, which can be used in maintaining the access control. Other than that, you can see in the next page, models like attribute-based access control, multi-agent control framework, and ledger-based architecture, etc. These researches were done around the year 2005 to 2022. Now, as we have seen in the research, as when we did our research, we have seen that we cannot predict what proposed solutions are effective in the real world setting. But yes, what we can say is that since both blockchain and IoT are ever evolving, then based on that, fundamentally privacy goals can be achieved and that can be set. And if we see, then the research that can be done in the future can be based on the integrity that can be done using digital signatures. For authentication, we can use shared secrets. For authorization, we can use MAC policies. And for confidentiality, we can use public key encryption. So, throughout our review, we have provided a comprehensive overview of how blockchain technology interacts with the Internet of Things, and from which we can conclude that by using these various concepts, IoT's next generation will be revolutionized by blockchain. For security issues like for authentication and access management of IoT devices, smart contract proposals can be used. To manage problems of unauthorized access IoT devices, attribute-based access control can be recommended. And with this, it can be concluded that on recognition of all of these, it can accelerate citizen, government, and business engagement after all. So these were the references which we have used in our research paper. And yeah, thank you so much. We are open to any questions.
Thank you for your presentation. Dear participants, do you have any question about the paper? Okay, no questions. Thank you again. I wish you success in your career.
Thank you.
Next paper belong to dear Hüseyin Falih Mehdi.
Yeah, Love, I think you may please present the paper, please.
Sure.
Yeah,
Can you
thank you.
Can you hear me all right?
Yes.
Yeah.
Thank you for confirming.
Samyukta Shahu, please mute your mic, please.
You can share your presentation.
Can you see my screen?
Yes. You have
Okay.
10 minutes, please.
Yeah, you are online now. We can
Yeah.
also see your screen. Thank you.
Thank you for confirming. Greeting, friends. My name is Lav Kumar Gupta. I'm here to present this paper titled Idea Mining from Online Reviews Using Transformer-Based Natural Language Processing Task. Just a brief introduction about the concept. So we are in the age of social media and e-commerce where we have like multiple sources of users providing their reviews. And we have like multiple sources and these reviews can be a source of, innovation in terms of how you provide your services or how innovative a new feature that you can add to your product. But not all of these reviews are useful. So we must have a way to filter the reviews which are not meaningful to us. And there are many ways to actually use reviews to begin idea. So for example, some ideas can come from, like many people suggesting the same thing. So you can sense that, okay, there is a demand in the market about that such a new feature, right? And there could be reviews which are very, less in number, but they might provide you some hidden insight that nobody else has figured out. So it ranges between these two extreme, like number of instances of similar views and very few instances where people have such reviews. But for our topic, we will be focusing on suggestive reviews. So we are focusing on the reviews that people might have suggested some changes or suggested new feature. So we are trying to mine ideas from such reviews. So having said that, the idea mining itself is a subjective task. So it needs a manual intervention. It's a creative process, and it involves some kind of manual effort, right? So basically, somebody has to vet those reviews out, whether they make sense or not. But in the recent advancement of transformation-based models, which are able to retain the context or the meaning of the sentence efficiently than their predecessors. So even though the idea mining is a subjective task, we can automate some of this process, efficiently. So if you leverage those tasks who can retain the context well, you can use them to automate and improve the overall idea mining process. So that is the intent of this paper. So this is a idea mining framework like proposed in the previous work. Basically, it involves analyzing a huge text corpus and applying your filtering logic, and you will have like some kind of metrics where you identify similar ideas and you try to cluster them so that you will evaluate them at later stages. And so once you evaluate those, a group of reviews, you may come up with new ideas. So that is the existing idea mining framework. So why transformation-based NLP task? So the major advantage of using transformation-based models such as BERT and its variant is that they provide like positional encoding of the word in a sentence, right? So positional encoding in the sense like no matter where the word is in the sentence, it actually has the context of the whole sentence, right? So even if the word in the sentence are jumbled, and if the meaning is still intact, they will have the same contextual information. So this is important to what do you call preserve the context of the sentence. And other benefit of using this transformation task is like parallelism. So the predecessors to the transformation based task used to be like RCNN based model, which would only take words sequentially, one at a time. So it was like hard to train, but the transformation based task can, like, you can input the whole word in the sentence in parallel. So it allows to train on larger data set. So if you train on larger data set, the efficiency of those model will be better. And also the availability of pre-trained models. We already have a huge set of models, and you can fine tune as per your like domain specific requirement as well. So it provides you a good start. You can hit the ground running with existing model and fine tuning as you go, as you proceed. So what are the changes that we are making in the idea mining framework? So we are trying to inject a classifier based on this transformation based NLP task, which will tell us whether a review is suggestion or not. So in that filtering logic, we are implementing NLP task. Again, when you measure the similarity between the sentences so that we can cluster them together. So we are also using a BERT-based sentence transformer. So these are the two places where we're trying to inject NLP tasks to gain like overall efficiency. So this is the architecture or the flow of this model. So we will use a suggestion classifier to classify the text corpus to see whether it is a suggestion or not. And once we have a corpus, a filtered corpus, that we will inject it to the sentence similarity model, and that will cluster the sentences which are formed together. And these clusters will be again further evaluated by a person so that they can generate ideas from it. If you look at the suggestion classifier, to classify whether a text is a suggestion or not, we use a SAM-Eval data set. So it is a workshop that happens every year where they provide these NLP tasks. So we used those data set which has around 8,500 reviews, out of which 2,085 are suggestion and rest of them are non-suggestion. And we used a BERT-based encoder to create the vector representation of the token. And again, it comes with its own preprocessor, which will convert the raw text into a tensor. So that's what we use. For the sentence similarity model, we use a data set, Amazon data set for fine food review, which has around 500,000 reviews. And we filtered like top 2,000 of them, which were suggestive in nature. And we tried to build a cluster of 5 similar sentences. To evaluate whether the sentences are similar, we use cosine similarity matrix. And to encode, we use like a BERT-based encoder called sentence encoder. And if you look at the results, so these are some of the idea-worthy reviews that the system has suggested. So if you can see the highlighted text, so it actually adds tells you whether what you can change or add to the existing product. So this is the result. This is the suggestion that the system gave. So some of the future extension will be to improve the suggestion classifier. The data set that we have used is only for the evaluation purpose and didn't have good data. And maybe if we can have like data set around suggestion, we can improve the performance as well. We also wanted to evaluate with newer language models. Since we used a domain specific task, in this case, food review, and you can use your own domain specific data set as well. So those could be the future extension of this work. And these are some of the references that we use in the paper. I'll pause for a while and see if there are any questions.
Thank you for your presentation. Dear participant, do you have any question about the paper? Okay, no questions. Thank you again. I wish you success in your career.
Thank you so much.
Next paper belong to dear Imene Latreche. Are you ready to present? Dear Imene Latreche, are you ready to present?
Yes, I'm ready to present, sir.
Okay, you can start if you are ready. You have 10 minutes, please.
Okay, sir.
You can share your screen.
I'm trying to partage my screen. Is it clear?
Yes. You have 10 minutes, please.
The screen is clear.
Yes.
Is it obvious to all the participants, my screen? Okay, I will start now. I'm honored to participate in this prestigious scientific conference to present my work entitled CNN and STM to identify the most informative EEG-based driver drowsiness detection brain region, prepared by me, Latreche Iman, Professor Zlatmir Siham, and Professor Kazar Aqba. Our table of contents is divided into 4 sections: a brief introduction that presents our motivation and objectives, the proposed system section, where we will present the overall architecture of our work, experiments and results section, and finally a brief conclusion with some future works. Drowsiness, known as fatigue, is the psychophysiological transition state between alertness and sleepiness that decreases a person's concentration and performance while increasing his reaction time. Drowsiness can be dangerous in a variety of situations, including driving situations. Many reports have regarded driver drowsiness as the third cause of traffic accidents following the high speed and the alcoholism. According to the National Highway Traffic Safety Administration, the results of police reported crashes over 1,500 deaths and 12.5 billion in monetary loss. So according to these statistics, it's necessary to develop a system that can detect it quickly and accurately to prevent road accidents and reduce the fatality rate. In this regard, several researchers have employed numerous approaches and methods to detect drowsy drivers, such as the electroencephalogram EEG as the most used monitoring approaches, and the 2 well-known mechanisms, machine learning and deep learning as detection methods. EEG records are acquired from the scalp surface using a system of electrodes placed in various brain regions based on the International 10-20 system, as is shown in Figure 1. Putting a wearable device on the scalp while driving can result in some drawbacks, such as making the driver uncomfortable, as well as the high cost and complexity of analyzing and classifying all channel signals. It is necessary to identify which brain region is the most informative for detecting drowsiness to reduce the number of electrodes. The main objectives of our work is comparing the results of the frontal, parietal, occipital, central, and the temporal regions, as well as all regions, using an available online balanced and preprocessed Browser EEG dataset with 32 channels and a deep learning model to determine which one is more significant. Then we have validated the result with 10-fold cross-validation technique. The proposed system figure to display the overall architecture of our system, which present the main architecture of our proposed work that started by acquiring the raw EEG data, preprocess the data, and then fed it to the classification model that classify whether the driver is in a drowsy state or alert state. To get more details about our proposed model, we have used a CNN model as a feature extractor to extract feature from EEG signals, and LSTM as a classifier to classify whether a driver is drowsy or alert. The model consists of 1D convolution layer with 128 filters of size 3 and stride 1, a batch normalization layer, a ReLU activation function layer, and a max pooling layer with the pooling size 4 and the stride 4. Finally, a 64 units LSTM layer is placed before the output layer. The one-hot encoding have been used to our labels, so our output is as shown in figure 3. Experiments and results. Our dataset is the original dataset was collected from 27 individuals using QuickCap NeuroScan for 90 minutes. The used dataset is in our study is extracted from the preprocessed version of the original dataset. It contained 30 EEG electrodes and 2 reference electrodes. The preprocessing steps applied to the original dataset are described as follows. The raw EEG signal was filtered by 1 Hz high pass and 50 Hz low pass finite and pulse response peer filters. It was downsampling from 500 Hz to 100 to 120 Hz. We have used the AAR automatic artifact removal to remove artifacts, then segmented the data into 3-second window. 2,022 samples were extracted from 11 subjects, where 1,011 samples were drowsy and 1,011 samples were alert. We have used the 10-fold cross-validation method in which we shuffle the data and then divide it into 2 parts, training with the 90% and testing with 10%. We desampled the test set to use it as a final evaluation, and we utilized the training data with the cross-validation technique as described in the figure 5. For each execution of the cross-validation, with each brain region, we save the best model found to use it in the final evaluation. All experiments were conducted in a Python 3.6 environment with Keras and TensorFlow using the GPU graphical processing unit, power provided by the Google AI artificial intelligence platform and Colab. The table below represents the obtained result by our study. As the dataset is well balanced and the problem is a binary classification, we can consider the accuracy as the comparison matrix. From the table below, which represents the main results of the 10-fold cross-validation for each region, we can note that the central region is has the highest accuracy with the 73.55% and a precision of 76.77. For the final evaluation, also we can note that the central region is the most accurate, or the highest accuracy with 78% and 80.4% as precision. From table 1 and 2, we can conclude that the central region is the most informative with a mean accuracy of 73.56 66% and final evaluation accuracy with 78%. In addition, from figure 6, we can notice that the accuracy obtained for each fold in this region range from 70 to 80. However, we also can see that the occipital and parietal region gave good results compared to the others. So we have tried to combine those regions to find the best combination to improve the results. Table 3 displays the average results of the 10-fold cross-validation results for region combination. We have combined central occipital parietal as SOP, central occipital as SO, central parietal, and occipital parietal. From the table, we can note that the central occipital have the highest accuracy with 75.53 and precision with 77.48. We found that the combination of the central with the parietal gave the highest mean accuracy and final accuracy, which is very good in terms of accuracy, precision, and electrode number, 6 electrode. The confusion matrix of the CO region we have in the test set 203 cases. We can notice that the results are good for the central occipital region. As conclusion, we can say that our study displayed that the central region was the most accurate in terms of one region with an average of 73.55%. Trying some region combination make us know that the combination of the central and occipital regions gave the highest average accuracy and final evaluation accuracy with 75.53%, 82% respectively. We recommend using the CO region in the future drafting study to get more accurate systems. As a future work, we hope to use more subject and other data sets, big data set, as our data set is small a little bit. Using deeper model to get a good generalization and a robust system. Using optimization algorithm to choose the efficient set of hyperparameters. Thank you for watching. If you have any question, I'm here.
Thank you for your presentation. Dear participants, do you have any question about this paper? Okay, no questions. Thank you again. I wish you success in your career. Next paper belong to.
Thank you so much, sir.
Okay, thank you. Next paper belong to dear Tvetelina Miladenova. Are you ready to present? Dear Tvetelina Miladenova, are you ready to present? Dear Tvetelina Miladenova, are you ready to present? Okay. Next paper belong to dear Feng Zifu. Are you ready to present? Dear Feng
Yes,
Zifu.
yes.
Okay.
Yes.
If you are ready, you can start your presentation.
Yeah.
You have 10 minutes, please.
Got it, sir. Can you see my screen?
Yes.
Yes. Okay. Hi, everyone. The title of this presentation is Automated Optic Disc Encapsulation for Glaucoma Detection from fundus images using the Detectron tools, MaxCAL-CNN. I am a graduate student at Ohio State University. My name is Fengze Wu. I would like to thank the conference organizer for giving this opportunity to me to present our work and accepting our paper. Glaucoma is a chronic degenerative eye disease. It presents a significant disease burden, which affects 80 million people worldwide, and it is the leading cause of blindness. The US economic cost for glaucoma care is estimated at $2.86 billion annually. So early detection for glaucoma is crucial. Individuals with glaucoma typically do not show symptoms for years, and their case may become advanced before they notice visual loss. And about half of individuals with glaucoma are not aware that they have the disease, even in developed countries. Cup-to-disc ratio is an important structural indicator for glaucoma. Individuals with glaucoma typically have larger cup-to-disc ratio, which is larger than 0.7. And the cup-to-disc ratio is the vertical diameter of optic disc over the vertical diameter of optic cup over the vertical diameter of optic disc. And we propose an automated method using MaxCNN for object detection and instance segmentation. So MaxCNN is an instance segmentation framework and an extension of FastRCNN obtained by adding a computational overhead to the Max branch. This architecture outperformed all single models results on the COCO 2016 challenge. In this work, 2 models were trained to detect disc and cup area separately. Our MaxCNN model is implemented from Detection2, a Facebook AI research library that provides state-of-the-art object detection and segmentation algorithm based on PyTorch, with accuracy further improved in its Detection2 implementation. We use the COCO instance segmentation baselines with MaxCNN and the ResNext 101 FPM backbone in our study. The input image is first fed to the pre-trained ResNext 101 FPM model to obtain feature maps. Then the region proposal network scans the given feature map and output multiple regions of interest. The feature map and the region of interest are sent to the ROI align block for each region of interest to have fixed size feature map. Finally, the feature maps are sent to fully connected layers for object detection and classification, and also sent to a fully convolutional neural network for pixel segmentation. We trained 2 MaxCNN models. One was used to detect disc from fundus images, and the other one was used to detect cup from segmented disc area. The bounding boxes of disc were cropped from region of interest, and we applied image augmentation to both model training, including horizontal flipping and resizing. Our dataset is obtained from Retinal Fundus Glaucoma Challenge, also known as Refugee Challenge. This challenge has 2 texts, optic disc cup segmentation and glaucoma classification. The refugee dataset consists of 1,200 color fundus images with ground truth disc and cup segmentations, and glaucoma labels by 7 independent glaucoma specialists. This dataset is the largest existing dataset of fundus images and glaucoma. The images are divided into 3 sets, 400 for training, 400 for validation, and 400 for test images. Given a fundus image, the optic disc and cup area are detected and joined by bounding box. The disc and cup polygon annotations are included in the dataset based on the majority voting results from 7 experts as ground truth. Manual annotations of the disc and cup area by glaucoma specialists are labeled in colors, where disc is black, cup is black, disc is gray, and the rest areas are white. By instance segmentation, our model can also predict the shape of the interest area and output pixel level masks. This function will give doctors more details in glaucoma screening. In order to study the performance of our proposed method, we compared it with the results in the refuge challenge using the same dataset and evaluation matrix. We applied our models to 400 test images, and our model is able to extract dis and cap regions from all the images. The evaluation method is based on DES index for segmentations and the mean absolute area of VCDR estimations. DES index is 2 times the area of overlap divided by the total number of pixels in both images. Our method achieved highly accurate results with a DES index of 0.9622 for disk, DES index of 0.8870 for cup, and an MAE of 0.0376 for VCDR on the testing images. Our results outperform all refugee teams. We improved the disk and cup DES index score over top teams by 0.2% and 0.4% respectively, and reducing the cup disk ratio mean absolute error by 9%. Small improvements for disk and cup segmentation can lead to a great progress in cup to disk ratio estimation. Our method provided an accurate and automated solution for disk and cup segmentation and VCDR evaluation. We used 2 Tesla V100 GPU cards for our training and detection. The proposed method took 4.42 seconds on average for model loading, 0.12 seconds on average per Phonos image for disk detection, and 0.08 seconds on average per cup detection. The proposed method is much faster than manual annotations. This shows the time-saving advantage of this method in real-life applications. This work still has some limitations, since images in the refugee dataset are from Chinese population only. Future works need to include more diverse datasets to improve the generalizability of the presented method. Moreover, other deep learning algorithms, such as ensemble learning, may further increase the model performance. In summary, our proposed method provides an accurate and automated tool for segmenting optic disk and cup areas and determining vertical cup disk ratio from fundus images, addressing the critical need for early detection to reduce glaucoma-related blindness. This work was in part supported by the Ohio Lions Eye Research Foundation. Also, thanks to my PI, Dr. Gao, and my colleague Marion for the help with this research and paper. Thanks to Refugee Challenge for providing this data. And thank you all.
Thank you for your presentation. Dear participants, do you have any question about the paper? Okay, no question. Thank you again. I wish you success in your career, dear Feng Ze Wu. Next paper belongs to dear Olena Serhienko.
Hello, my name is Natalia Chernova. I will present the work.
Okay.
I'm the co-author.
Okay. You have 10 minutes, please.
Thank you. So, hello everyone. My name is Natalia Chernova, and I'm glad to present to you our work, Ukraine stock market spatial dynamic analysis. Our goal was to develop and implement the algorithm for analysis of the stock market of Ukraine. And during our work, we have solved such tasks as comparative analysis of the stock market of Ukraine and stock markets of different countries, among them developed and emerging ones, analysis of the influence of internal and external factors on the development of the stock market of Ukraine, and forecasting the level of stock market. The level of stock market index in Ukraine. This slide presents you the dynamics of the Ukrainian stock, one of the main Ukrainian stock exchange, PFTS, and you can see the ascending values during the period till 2020. Here you can see the main steps of the proposed algorithm. You can see that the first one is comparative analysis, and it has 3 subtasks. Formation of the initial system of indicators, classification of stock markets into homogeneous groups, and selection of representative countries representatives in each group. Step 2 deals with analysis of the influence of internal and external factors of the the development of the stock market in Ukraine. It has 2 subtasks: formation of the initial system of factors and modeling dependencies between stock market index of Ukraine and internal and external factors. And the third step deals with forecasting. Here you can see the list of countries which were involved in our research. We have the initial set of data, the initial data set. Next, you can see the comparative graphs for dynamics of Ukraine stock index PFTS and the main benchmark SP 500. And you can see that for the last 5 years, the dynamic, the Ukrainian stock market was not so volatile as the main benchmark. Here on the next slide, you can see the comparative figures for growth rates of researched indices for different developed and emerging countries. And as a conclusion, we can we make the conclusion that this data is rather controversial, and to deal with such a different time series, we need to modify them, and all next calculations were with 2 popular financial indicators such as risk and return. Here you can see the main formulas which are used to calculate the appropriate indicators of risk and return. And you can see that the measure of return is the statistical mean, and the appropriate measure of risk is variation. On the next slide, we present you can see the positioning of all countries which are involved in this research in the risk-return space. And as a conclusion, you can see that there are 3 outliers, such as among them are Ukraine, Cyprus, and Argentina. These countries but this and there are countries which demonstrates negative returns, but for Ukraine, but Ukraine is not among them. Next, we present obtained results. To classify objects into homogeneous groups, we have applied K-means algorithm, and in order to determine the optimal number of clusters, we use two indicators, sum of within class dispersions and sum of distances to cluster centers. And according to the obtained results, it was clear that it is necessary to classify initial set of countries into 4 clusters. Here you can see the obtained results for obtained 4 clusters or homogeneous groups. And you can see their characteristics such as mean risk and mean return for each group. Then, according to proposed algorithm, for each cluster, we determined the country, the representative country, and it was obtained as the country which has the minimum value of Euclidean distance. Here you can see the obtained results. You can see the members of each of 3 clusters. The third one consists of Ukraine and Ukraine, Argentina, and Cyprus, and for cluster for obtained cluster 1, 2, and 4, according to their statistics, we named them as sufficient performance, normal performance, and best performance. For each cluster, we obtain the representative country, Switzerland for best performance, Poland for normal ones, and China for sufficient performance. And according to our research, these countries should be should play a role of strategic benchmarks for Ukraine. From the other hand, these countries and the main indicators of their economic systems may be unattainable in the short term for Ukraine. That is why for short and middle term management, we suggest take into account other objects to choose which the criteria of the nearest distance from Ukraine may be used. And in this case, these representatives are the following: USA for best performance, Italy for sufficient ones, and Croatia for normal performance. Next, we have analyzed the influence of different factors on the functioning of the Ukrainian stock market. And we use the following initial set of indicators, such as money supply, exchange rate, gross domestic product, government debt, SP index, money supply to GDP ratio, and government debt to GDP ratio. We examined the linear relationship, we constructed the appropriate model. It was statistically significant, and but the appropriate correlation coefficient was only 0.76, and the appropriate coefficient of determination was only 59. So according to the obtained values of standardized coefficients, the most significant influence on the level of Ukrainian stock index is caused by SP 500 and such value as government debt to GDP ratio. Next, the last step was to obtain to obtain the appropriate model to be able to forecast future values of stock index, and we use two base models. They were Holt model, and the next one was linear trend model. And according to the obtained results, the best model, according to the indicator of mean absolute percent error, was a Holt model. And as a conclusion, we can say that the proposed algorithm for analysis for spatial dynamic analysis is based on methods of multidimensional statistical analysis, regression analysis, and time series analysis. It allows to classify the initial set of stock markets into homogeneous groups, position the stock market of Ukraine in this classification, determine those international stock markets that may be chosen as benchmarks for Ukraine, and determine the internal and external factors that cause the most valuable influence on the level of Ukrainian stock market index, and also forecast the levels of the index. The results of country's stock market classification have shown that Ukraine is situated in the group of worst performers. This group is characterized by the highest level of risk and rather low level of return. And the strategic aim for objects from this cluster is to increase the level of return, to decrease the level of risk, and to move into sufficient performance or normal performance. The results of model independencies between stock market index of Ukraine and internal and external factors have shown that the most significant influence on its level is caused by SP 500 index and government debt to GDP ratio. The first mentioned factor is not under control of the Ukrainian government. That is why the government may cause change in situation on the stock market only by managing the level of country's GDP or GDP to debt or debt to GDP ratio. The situation with the financial system of Ukraine is not determined only by the movements of the appropriate stock market. So future research will cover investigation of bond market peculiarities, its historical change, interdependencies between stock market and bond market, and the role of government bond market in Ukraine's economic system, and also the comparative research of core world bond markets. Thank you for your attention, and if you have some questions, I'll glad to answer for it.
Thank you for your presentation. Dear participants, do you have any question about this article? Okay, no questions. Thank you again. I wish you success in your career.
Thank you.
Next paper belongs to dear Ersin Şener.
Yes, I'm here.
Okay. If you want, you can start your presentation.
Thank you.
You have 10 minutes, please.
Thank you. My name is Ersin Şener. The paper title is The Wavelet Noise Tarima and the LSTM Method to Predict the Cryptocurrency Prices. In this paper, we study it. The presentation plan is the introduction and the literature review and the material and methods, results, conclusion, and references as this seen. The problem of price prediction faced by investors and in particular economists in the management of the money is a rather complex problem that has been attempted to be solved since the existence of the investment instrument. The solution to this problem is becoming more stable day by day within the limits of the technical possibilities. Cryptocurrencies are virtual medium of exchange first launched in January 2009 under the name BTC, Bitcoin, as an alternative protection for investment after 2008 mortgage crisis. We know the Great Depression. Cryptocurrencies have significant advantages and are a reliable currency compared to traditional currencies, both in terms of transactions and production methods. Known and controllable algorithms are used to produce this. To predict the rate of the exchange in the some of study in this area, USD GPM Forex price, they proposed a Wavelet noise ResNet model with the light GBM on the dataset taken at 5-minute time intervals. The data was manipulated with the Wavelet nosing and trades were predicted by classification by the ResNet CNN and the light GBM methods. OHLC values are used for the basis. The noise ResNet light GBM proved to be the most successful among 8 different models. Another study, they proposed a hybrid approach combining machine learning, artificial neural network ANN, and the support vector region CVR methods with the weekly data set of the Indian National Stock Exchange 50 Index. The composite by the maximal overlap in discrete wavelet transform method. Cryptocurrency price prediction is a time series problem. Also, we have known this. To date, countless applications have been made with time series where it is not possible to ignore the effect of the past for price prediction. The presence of the unit root in the linear time series analysis, in other words, the stationary of the time series is a prerequisite for this estimation of the model. Moreover, we are aware that cryptocurrency prices are non-stationary time series. We use the autoregressive moving integrated average ARIMA method, which is often preferred in the analysis of non-stationary time series. In the study, BTC USD, the United States dollar, which is considered as a problem for predicting the price of cryptocurrencies, an investment instrument is modeled between March 11 on the pandemic, COVID, also we know the pandemic time, March 11, 2020, and September 30, 2022. Using the Wavelet noise autoregressive integrated moving average, we are proposed this DARIMA and the Wavelet noise long short-term memory, the LSTM methods. The models are compared to the noisy ARIMA and the LSTM methods to determine the most accurate model. The data set consists of the daily and of day cryptocurrency prices of BTC used from the beginning and end days. BTC USD, the exchange rate between the US dollar and the BTC is calculated by the crypto coin comparison aggregate index. Also, we have known the cryptocurrencies has a lots of stock market. The triple C, A, and double G is the method of calculating the index in real time. The daily cryptocurrency price data of the BTC is collected from a free available website. It is calculated for each crypto coin in each currency by using from over 170 crypto markets. For the prediction of the BTC USD price, we consider the average values of daily opening, high, low, and the closing price as OHLC value. The general overview of the dataset can be found in table where also we have seen the date, open, close, and high, low columns in this study. The min max values and the other completely explanatory statistical values of this dataset, 934 observations can be found. Also, we have seen the count mean for all columns open, close, high, low. Standard deviation, mean, and the percentage and the max values can be seen in table 2. The main problem in price prediction or forecasting is not to find the exact price, but to draw an approximate conclusion with the least error. For this reason, an optimal predictive model for approximate price prediction was made based on the OHLC price value, which is the average of the also daily opening, high, low, and close prices of the BTC. The OHL price value is calculated at the time t using the form of equation 1. Also see the figure 1. You have seen the fluctuations and the volatility price on OHLC. The presence of the fluctuations of the volatility time series estimation affects the success of the estimation. To minimize the effect, a smooth time series is created using the wavelet transform. The data set to test the predictive performance of the methods. The data set is divided into 2 samples, the training and the testing sets. The training test consists of from March 11, 2020 and March 23, 2022. Representation percentage of 80 of the data and the 80 the data set can be divided into 2 data sets. The data set was normalized to be free of units. The Python packages also we have now the scikit-learn for processing min-max scaler. We use all the analysis in Python 3.9.9 version. Wavelet transform also denoising the method for fluctuations and volatility in the data. Wavelet transform is a mathematical approach. Also, we have now provides a time frequency presentation of a signal and allows one to determine how the time frequency information changes over time. It can represent the local features of the signal in the time frequency domain while displaying the time frequency features. A wavelet family is a great set of the orthogonal basis functions formed by translating and scaling functions and mother and father wavelet. We have now this. The normalized wavelet function is seen in equation 2. And this G is the scaling parameter and the K is the shift parameter indicated how much this wavelet is shifted. The presence in the denoising process for wavelet transform. The presence of fluctuations and volatility in time series estimation affect the success of the estimation. To minimize this effect, a smooth time series is created using the wavelet transform. The OHLC values are compressed into wavelet coefficients for wavelet-based estimation using the discrete wavelet transform DWT with WHs DB4 and the level 5. The visual sharing soft thresholding method was used to remove the white Gaussian noise from the data. The process of the data analysis with wavelet also we have now the noise-free data were encoded as wavelet noise DOHLC and added to the data set. The process used to remove white noise from the data set as shown in figure 2. In this process, the raw data get the composition from the discrete wavelet transform and get the scale from the shrinkage and the inverse discrete wavelet transform and the noise data is get. The discrete wavelet transform and the inverse discrete wavelet transform process can be seen in figure 3 and the discrete wavelet composition for level 5. D1 to D5, the A5, and our firstly data, and we can see the fluctuations denoising data. The OHL and the DOHL prices obtained by the constructions paradigm of Donoghue we give in the figure 5. The fluctuations have seen in this OHL values is smoothing and truncating from the data. Also, the predictions also can be good than the OHL values. We will be done it. Material and methods. The other methods is autoregressive integrated moving average is the time series methods. Is a general autoregressive that combines autoregressive AR process with a moving average MA processes to form a composite time series model. This model expressed as ARIMA PDQ includes three basic elements, where P represents the number of the terms from R, AR. The term D is the degree of the non-seasonal variation required for the stationary and the important for the model integration I. These two models and the MA is the moving average. Also, these two models of degree P and Q can be combined to form the following ARIMA model in equation 3. The ARIMA estimation, also known as the Box-Jackson estimation, was worked with the non-stationary time series by integrating with the difference method provided by the D term. The LSTM long short-term memory is a variant of the recurrent neural network, RNNs, we know also, whose mode of operation is based on remembering values from previous phases for future use. In iterative neural networks, whose architecture is shown in figure 6, the previous stage data should be remembered while predicting the next step. Each LSTM cell contains of an input gate, is see here, input gate X, H, this is the forget gate, and the output gate also here. We can say something about this figure. In the green rectangle, we can see the forget incorrected lines that carry historical data. At the beginning of each cell is a forget gate. The task of this gate, located within the green lines, is to evaluate the information from the previous cell and the current information from the activation function and decide which information to keep as a result. In this gate, which return as a number of, in this gate, which return is a between 0 and 1 as a result of the activation function. The sigma has activation function, and the result of the activation values of the represented can be forgotten. The input gate, in this input gate, we get the forgotten gate has a some information, and then get the xt value, and then we use some activation function that can be forgotten or that can be give the another output gate. Output gate within the blue lines. Also, we know the output lines, both prediction and determining the input, the next cell. We optimize, in this study, we optimize the hyperparameters of the LSTM. There are many LSTM hyperparameters also we know, but we occur only the optimizers and activation functions. There are 28 different combinations of the LSTM hyperparameters. Optimizers also CGD, AdaGuard, AdaMax, AdaDelta have 7 optimizers, and activation functions relo linear tangent hyperbolic and sigmoid function get the activation function with the fixed linear grade. The hyperparametric benchmarking of the DLSTM, we have seen the most accurately and the minimum root mean square error value for training test and the total. We have seen that is in the Adam linear combination for the minimum root mean square error value on lag1. Lag is the bench back propagation of the LSTM model. How get the some information about the back meaning of the lag. We use this here. The benchmarking can be seen in the loss value. Loss value, the LSTM prediction can be seen for the top 8. There are 28 different combinations. Also, we know to get the top 8 of them. The LSTM prediction loss value is the mean square error value. Benchmarking for optimizer activation function in lag1. We can see all of them. Some of these get the on the 5 epoch from 20 80. In 5 epoch after then the optimizer and the activation functions have fluctuations. You can see 0.2 in this valley, Loess Valley, we can get the Adam Rayleigh or the Adam linear, also the Adam optimizer get the most effective than the other optimizers, and the Rayleigh or the linear, we also decide to this one log benchmarking of from the root mean square error valley Adam linear in this section, and then go ahead. Leg backbenching for the LSTM and the LSTM. The LSTM also we have noted the noise value of the OHLC to LSTM, and the LSTM is also OHLC values can be seen there. The LSTM log value log 1 to log 5, log 3, log 5 have seen this here, and the LSTM log level can be seen there. Log 3 also most effectively root mean square error, also log 3, all the train test and the total level can be seen. Go ahead for our study. We'll use the log 3 for the LSTM and the LSTM method for that. Also, we have seen the daily OHLC and the OHLC DLSTM prediction between from beginning and the end. We've seen all the fluctuations and the estimation and the prediction can be seen for test and training term. This is a test term. We have seen the OHL and the DLSTM prediction test term can be seen. The fluctuations and the volatility can be seen in the OHLC, the red line, to smoothing by the OHLC and the black one, black line, and also can be overlapped for the LSTM method in this study. The other method we use, the cryptocurrency price prediction, the ARIMA and the DARIMA methods. Have 3 steps for this study. The process of estimating cryptocurrency using the ARIMA model and obtaining its predictions was performed using the following steps. Steps 1, it's checked whether the time series contains seasonality. The analysis continues for our BTC USD time series, which does not contain seasonality in its structure. Step 2, the stationary of the time series is examined with the unit root test. The degree of the integration is determined. If the first difference is stationary, the degree of integration of the series is I1. For the unit root test, the augmented decay Fuller ADP unit root test statistic was calculated. The ADP test T value can see calculated for the time series was not stationary at the significance level with the P value also have seen. The OHLC time series autocorrelation, the OHLC and the partial autocorrelation values distribution can see from this study. The series whose vertical is taken was stationary with the statistical value of the ADP statistics and with the significant level. The level of integration of the time series is I1 and the D is 1. In other words, it was determined that the estimation is made using the model ARIMA P1Q can be used for the further prediction. Step 3, our first order integrated time series is estimated with 25 different.
Sorry, dear Ersin Şener.
Yes.
We can't hear you.
Hello.
Hello. Okay.
Okay. Our first order integrated time series is estimated with 25 different ARIMA P1Q models for P min 0, P max 4, and the Q min 0, Q max 4. The PMD ARIMA packages in Python is used for model prediction. The following 3 conditions were evaluated together in model selection. Statistically significant AR and the MA coefficients, the result residues do not contain autocorrelation. The Gaussian statistic must be in the range of 1.7, 2.0, 3, the residues are examined on the parallelogram graph and expected to form a clean white noise sequence. The AIC value benchmarking of the AR-IMA model, we can see the for the 25 also the most popular 10 value can get this here, and the 3, 1, 2, P is 3, 1, D is 1, and the Q is 2. Also, the ARIMA model is the most accurate model for the OHL C values. The prediction of the OHL data with the ARIMA model is referred to the as the ARIMA. The statistical models of the ARIMA prediction model are shown in table 6. All the coefficients R and MA, AR and MA are the statistically significant level for p-value. Prediction of the OHL values via the LSTM and the ARIMA has been given here. We can see all of them. ARIMA has ARIMA and the LSTM models for OHLC. The OHLC, the LSTM and the ARIMA model can be seen both of them for this figure 20. For the prediction of the OHLC dataset with ARIMA, the procedures described above was applied accordingly. For the ARIMA model prediction of OHLC value, we get these steps for the OHLC dataset in the ARIMA model. The lowest information criteria, AIC, was proposed as the prediction model. All conditions for the model which we summarize in 3 steps are satisfied. The OHLC values are predicted by the autoregressive. R1, the first integrated model, and the MA model, which is influenced by the 1 mean values. The statistical values of this Durbin-Watson test statistics is given, and there is no autocorrelation in the residues. The root mean square error values of the AR-IMA. The LSTM model is to predict the OHL values, and the ARIMA model and the DLSTM models in predicting the OHL values are shown in table 7. Also, we have seen our benchmarking, our ARIMA, LSTM, DARIMA, and the LSTM minimum root mean square error can be seen in the DLSTM method. We proposed this method for using predicting time cryptocurrency time series model. Conclusion: traditional time series prediction methods require certain conditions. Considering this situation, LSTM is very user-friendly. It is difficult for any time series to satisfy the stationary condition and the other conditions. Although approximate predictions are made for cryptocurrency prices, we assume that our data stabilized with AR-IMA contains a lot of errors that cannot be compared with LSTM. Both the AR-IMA and the LSTM methods produced better results in the predictions we made for the data set stripped of white noise using value to noising compared to the raw dataset. The LSTM method is the method with the lowest root mean square in the OHLC price prediction. Our proposed DLSTM method contains 3 backpropagated information. In future studies, the results can be compared with the other price prediction methods. In this way, the effect of the wavelet-based approaches will be more evident. Thank you for listening.
Thank you for your presentation. Dear participants, do you have any question about this paper?
Yes, I have some questions.
Okay, please.
Could you hear me?
Yes, okay.
Yes. First, I want to understand something. These wavelet functions, did you use wavelet functions for pre-processing and after the
I cannot
Sorry, dear Ezgi Bingöl, your voice is very noisy.
Sesimi duyamıyor musun?
Can you repeat the question,
Okay.
please? Your noise is very your voice is very noisy.
I cannot hear.
Yes.
Are there any questions?
Dear Ezgi Bingöl, you can write your question.
Or you can get information. You can use this mail addresses. Also, you have recorded this video.
Okay.
Thank you.
Pardon, şimdi sesimi duyabiliyor musunuz?
Yes.
Yes.
Okay, I want to learn something which I understand is you use wavelet transformation for pre-processing. After denoising data, you apply this time series predictions, or am I wrong?
In this study, we use this denoising process. Also with Donald Jones team. And the some of study use the Dawbex for denoising data. We get this denoising data reprocessing, and the visual shrink also give the most effective results more than the other reprocessing wavelet denoising search. We would do lots of sample for DOHL, and we get most.
Yes, I understood this. But what kind of noise do you have in data? Why do you need this?
We have the noise also. We have Gaussian noise in the fluctuation. We get this Gaussian noise. The noise we use the visual shrink.
Instabilities. You have instabilities, and you want to normalize it.
Yes, okay. The standard deviation divide for we use visual shrink. Also, you have seen this soft threshold.
Yes.
Are there any questions about? You can contact with me for the this mail. Also, have seen.
Yes, okay, reasonable. Actually, I do similar things on another subject.
Yes.
I did also some pre-processing and then another time series prediction method. Maybe we can discuss later. Thank you very much.
Thank you.
Thank you. Dear participants, do you have another question about the paper? Okay, no questions. Thank you. Again, I wish you success, dear Ersin Şener.
Thank you.
In your career.
Bir şey sorabilir miyim çabuk? Sesimi duyabiliyor musunuz?
Yes. Buyurun.
Ben organizasyonu, benim mailimi aldınız mı? Ben de sunumumu yollamıştım cumartesi için.
Onunla arkadaş ilgileniyor da ben size Turgut Bey'e söyler misiniz diğer şeyde oturumda?
Diğer oturumda tam ona mail attım da geç kalmadım değil mi cumartesi günü şeyleri için?
Süreci o takip ediyor. Ona sorarsanız daha iyi olur.
Tamam, çok teşekkür ederim. Bu oturum kapandı galiba değil mi?
Yok, kapanmadı henüz. Var, birkaç kişi var.
Bir kişiden mi var? Tamam.
Evet.
Okay.
Kolay gelsin. The next paper belongs to dear Ali Gammer Kahami.
Yeah, it's me.
Yes. You can start if you are ready. Your presentation. You have 10 minutes, please.
Okay. Hello, everyone. I'm glad to be here. My paper called Which Keyword Extraction Method Performs Better for Emerging Technology Detection. My name is Ali Ghaymaghami, and I'm under the supervision of Dr. Andia Shifarova and co-supervision of Dr. Ashkan Ebadi in the University of Concordia, Quebec, Montreal. So we want to answer the question of how to detect emerging technologies. There are some key attributes of emergence based on Rotolo et al. Novelty, growth, coherence, impact, and uncertainty. There are different methods from expert opinion to analysis of R&D publications, and different approaches from single aspect metrics to machine learning approaches to answer the question of how we can detect emerging technologies as soon as possible. So we first want to know how to detect emerging topics. There are so many papers that have been worked on this topic. Some of them use emerging topic detection with indicators. Some of these indicators are keyword-based indicators. Some of these methods are multi-layer indicator-based methods. Some of these methods can provide emergence score, and only some of these methods can provide emergence potential based on all the attributes of emergence. We selected one paper that have applied all these methods in one method, all these attributes in just one method, and we use that in our process. Qaim Aghami et al. Used this in one of its methods. So we want to make the problem a bit larger, how to detect emergent topics in a domain with keyword extraction methods. We want to derive easy to use indicators via text analysis from science data resources. By analyzing science literature, abstract and title data sets to devise practical emergence indicators. To identify emergent topics, that means the topical context that captures emergence attributes. Our indicators to give us the emergence score independent of data set characteristics. So the whole method would be something like that: data analysis, emergent topics, and emergent scores. So this is the whole conceptual flow of the work. As you saw, we want to detect emergent topics. But how we can detect emergent topics? First, we derive data from our data sets, we pre-process them, and then we want to extract some keywords from these data sets. We apply some keyword extraction methods. As you see, we have Yake, Raccoon, Rake, topical page rank, topic rank, TF-IDF, text rank, position rank, single rank, KP minor, and the BERT methods. We don't go through all these methods, but I just want to mention that all these methods are unsupervised learning methods. We use these methods to capture the keywords of the data sets that we are talking about, and we evaluate. And then, based on some emergence metrics like growth, novelty, collaboration, and impact, we capture emergence score or emergence point based on the paper that we taught previously. So the main problem and question is how keyword extraction method, which keyword extraction method performs better for emerging technology detection. There can be some sub-questions. For example, which keyword extraction method can extract more emerging technologies? I explain it later. Or which keyword extraction methods can extract emerging technologies with higher emergence point, which means higher emergence potential? Or which keyword extraction method can perform faster in emerging technology detection. We use data of Web of Science, including 7,500 pairs of artificial intelligence in the time span of 2010 to 2019, and 2,000 patents of artificial intelligence in the years between 2018 to 2019. You can see the annual distribution of the publications in the WOS data set, Web of Science data set, in the time span of our evaluation. So the main thing that we want to evaluate is the emergence point. Emergence point is a metric-based number that shows how much potential emergence a term has. It is based on the 4 attributes of novelty, growth, impact, and collaboration. The methods calculate the metrics for each term and assign a value to each attribute based on the number of terms in papers or patents. So this is the whole methodology. We have the data, including papers. We extract title and abstract of each paper and perform keyword extraction. The keyword extraction extracts 20 terms of each paper that has the highest degree and grade of that keyword extraction method. And we measure the elapsed time for this keyword extraction process. Then we calculate each term's score for all the papers in the data sets and rank the 500 highest terms of each method. Then for these 500 terms, we measure the emergence point and rank them based on the emergence points. After removing undesirable terms by the expert opinion, we compare these methods and how they can detect these emergence terms. For example, we have the results based on the implementation time of each method. As you can see, many of these methods have the same implementation time, except for one method, rake, that is extremely fast. And as you can see in the next slides, it's worked pretty well. So you can see the number of terms after each step of removal. As I talked about it before, we have 500 of terms, and we want to evaluate how much of these 500 terms are meaningful and have the potential of emergence. As you can see, we have removed general words. For example, words like data or big. In our data set, they don't have meanings, or non-useful terms. For example, words like several methods. It doesn't provide us with information. You can see the final results after these removals. As you can see, some methods, for example, topical page rank, text rank, position rank, and single rank, can have more useful result at the end. As we talked about it before, the most important thing for us is that we have the most potential terms. We want to have them, the terms that have the most potential. As you can see, we have the sum and average emergence points of each method. It is very dependent on how many terms we have. And as you can see, single rank, text rank, topical page rank, and position rank work better in this criteria as well as the previous criteria. In our process, we concluded that the BERT method can introduce us with some results that are meaningful. For example, the top terms of the single rank and the BERT rank, you can see them. For example, convolutional neural network, deep reinforcement learning, machine learning models, and big data are the top terms of the single rank method, and the BERT has convolutional neural network, CNN, deep reinforcement learning, machine learning models. I just wanted to compare them a little bit to have a better idea that what we have done. In conclusion, I can say that except for one method of Raccoon, other methods were successful in the process of extracting keywords for emergence detection in artificial intelligence domain. Rake method was extremely fast in the process with reasonable results. We suggest that if we have a big data set, very, very big data, we can use this method that can work very well in a reasonable amount of time. Our result also showed that 4 keyword extraction methods, namely single rank, text rank, topical page rank, and position rank, performed better in extracting high quality and high potential terms by expert opinion. However, some other methods such as BERT also performed very well in extracting top emerging terms. All in all, we say that implementation of 2 keyword extraction methods, automatic keyword extraction methods, can provide us with insightful results, and we can combine, for example, BERT method with single rank to have all the terms that are high potential. We also have had a limitation in our work, so we can have other future works to compensate this limitation. For example, our evaluation is limited. Other domains can be used other than artificial intelligence to evaluate our work more thoroughly. The methods in this paper were all unsupervised learning methods. One or some other supervised learning methods can be used to compare supervised and unsupervised methods of keyword extraction in the process of emergence detection. Thank you very much, and I would be glad to answer your questions.
Thank you for your presentation. Dear participant, do you have any question about the paper? Okay, no questions. Thank you again. I wish you success in your career.
Thank you.
Dear participants, first session of the symposium is over. Thank you for your attending. I want to end the session. Hope to see you at next session.
Thank you. Thank you, everyone.
Thank you.
Thank you, sir.